Okay.
I should mention I'm going to record this if that's okay.
Yep, got it. Very good. So yeah, it always makes me cringe a little bit when somebody calls me a combine expert, because every trip that I go on, I learn something new. So in any case, as Stacy shared, I have been around combines for a number of years. Starting in field test, as she said, as an intern, and then moving into the design group, and then now just recently, this is actually my second week on the job as the product marketing manager for New Holland. So this is kind of my first formal presentation in this role. But like she said, if you have questions along the way, don't hesitate to ask. I suspect if you guys are all seed producers and have been running New Holland combines, there's maybe not that much new that I'm going to share with you, but we'll reiterate a few basic things. And I'm certainly interested to hear about any specific challenges or questions that you have as we go through the presentation. So I'll start with kind of a little bit on CR combines, and then we'll touch on CX combines, and then we'll save some more time at the end for questions. But certainly if something comes up along the way, don't hesitate to speak up. So briefly for CR combines, I would say a few key settings, things that we can look at, and I'm assuming that some of the primary concerns being seed producers is absolutely minimizing damage as much as you can, and so that's kind of where this slide is. Where these slides are aimed, but if you have other concerns, please speak up. So I would say, kind of starting from the front, the feeder, of course, make sure that your feeder chain's properly tensioned and that you're using an appropriate drum position. I expect many of you are probably using draper heads, and normally we're running our drum fairly well up when we're running, particularly when we're running draper heads. If we move rearward in the machine, an error that we sometimes see in soybeans is guys that don't realize or forget to change their DFR speed to the low range. So the normal low range would be 640 RPM with the pulley change at the right hand side of the machine. There is also a DIA, or I should say an FI, a field install kit, to take that to even a lower speed, down to 550 RPM. So that's maybe something interesting for you if you're not already using that. In terms of rotor speed and concave clearance, generally speaking, I would say to start with the book settings. That's generally been fairly positive for me. I think our recommended settings are fairly accurate. Obviously with a stronger emphasis on seed quality, you may find yourself at the lower end of the rotor speed ranges, and maybe the wider end of the concave clearance if you can get away with it. However, I guess I suspect that you guys probably run into early frost up there that maybe create some challenges in terms of nice uniform soybean maturity and that sort of thing. So do you face a lot of problems with kind of like rubbery pods that frosted too early that you have that are challenging for you?
Yes, we have ran into that on with early frost, which, knock on wood, is not going to happen to us this year. But also on the flip side, we've had a few dry, extreme drought conditions where things have died prematurely and kind of locked in some green content on the pods. So yeah, we can relate to this.
Okay, certainly. And I guess when I've been in those conditions in the past, I probably have a tendency to start with a little more rotor speed and try to get those things out with a little bit more rotor speed. I mean, obviously it's a challenge, right? You're between speed, which can certainly cause damage, and concave clearance, which also can cause damage. But I generally probably lean towards speed myself first, and with that, try to do as much of the threshing in the rotors as I'm able to, and we'll get to that a little bit later. The other thing I guess I would always kind of kind of recommend is to make sure that your concaves, that you have the concave set parallel and concentric, following the procedure in the manual. Once in a while, we run into some problems there where with just a little bit more tuning and setup, we can do a better job. In terms of the transport vanes, generally speaking, faster transport vanes will produce less damage and reduce your power consumption, assuming, of course, that you can appropriately manage losses. You may, if you're fighting losses, generally speaking, some additional spikes in the back of in the separator area are usually fairly effective. Speaking for the twin pitch rotors. In terms of concaves and grates, I guess normally I prefer to run round bars in a soybean or a corn and soybean mix. Understanding that you might be in some tougher thresh conditions there, the round bars may not be able to help you to get those some of those green or tough pods out quite as well as like a universal grate would. I was talking to Kevin Johnston. I don't know how many of you are familiar with him, but Kevin is the regional product specialist for combines for your area. He was suggesting that he likes to run the universal concave with every other wire pulled in the rear 2/3. Yeah, keep the wires in the front 1/3 to kind of do a little bit better job of threshing out, and then try to get that stuff separated and out of the rotor as early thereafter as you can stand. In terms of cleaning system, I haven't gone into much detail here. Generally speaking, I'm going to start with the book settings on cleaning system, and probably emphasize tailings management. Particularly in a hard thresh situation, I like to do as much of the threshing as I can in the threshing system rather than relying on my tailing system. But in some conditions, and Kevin, when we were discussing it last week, had mentioned that sometimes he does see a need to put in a spike cover in the rethresher in order to work out a few of those last beans. Some regions I've been to actually prefer to let those green beans go, just because sometimes they create more storage and handling problems than what they're worth. On the flip side of that, I've been like down in the Delta, Louisiana, Mississippi area, and those guys are desiccating most everything. And they're of the opinion of, hey, let's get all those green beans in. They're harvesting at 18% a lot of the time anyways. They want to grab those green beans and they're going to run it through the dryer, and they're maybe a little bit less concerned about that. So a few comments there on cleaning and tailings. And then I would say just in general, I've headed it under grain handling here, but it's kind of a general statement. It's good to just do kind of a regular, especially a preseason kind of inspection, and also throughout the season, make sure that you're keeping your feeder chain, your elevator chain properly tensioned. That can help with damage, and be aware of any discontinuities that or component wear that can, auger flight wear, that kind of thing that can contribute to damage. Things like clean grain elevator doors that aren't quite installed correctly, and so they're not properly shingled. Those things can have a rather significant effect when you're in a sensitive situation and if you're not aware of it. And I guess the one other comment, and you guys are probably all well aware, but damage tends to be a cumulative effect. So it's, in other words, it's not that it's that single hit that breaks the bean open. Often it's a combination of multiple hits throughout the system. So each of those areas that we can make a reduction in has a cumulative positive effect. Moving on to some of the kits that you guys are maybe already using or maybe interested if you're not using. So like I mentioned earlier, we have the 550 RPM DFR drive kit. So this is like a very slow position. It's a kit that includes an extra pulley or a different pulley and a different belt to slow that DFR down further if you feel that you're getting some damage in there. Round bar concaves, like I mentioned, that's kind of my normal preference, but recognize that you may have some unique situations there that may not allow that. Also, round bar grates, those are available. We've on the other side of my old job when I was wearing my red hat, we certainly ran into some times like down in Brazil where we were up against some green, either really green stem conditions or green weed conditions where we were faced with a lot of module plugging, and the round bars can certainly help with that as well. So any questions around CR content before I move on to the CX?
Hey, it's Clayton Harder. I have a question if you got a minute.
Yeah, go ahead.
Hey, do you ever recommend, or is there a circumstance whereby awning plates or filler plates would be considered appropriate to help thrash out green pods or green beans? One that maybe jumps to mind is if you have really low yield or low material due to drought, say of the last couple of years, or is speeding up the rotor and potentially tightening the concave still the best choice to go?
That's a good question, and we've normally the normal response is, well, start with your rotor speed and your concave clearance, but definitely when you get into those tougher conditions, I'm not afraid to try stuff like that. Again, referencing some of my prior red experiences, we've gone to a hard thresh module up in the front, that sort of thing, where we can hold that stuff in a little bit longer, as long as we can do some of that threshing work without inducing more damage. Hold it in a little bit longer and then get it threshed out and then let it release. I'm not opposed to trying that if that's what your observations and the conditions indicate.
Thanks.
Any other questions? Else we can move on to the CX. So I'm gonna come out and be very honest with you that I have a lot less experience on the conventional machines than on the rotary machines, and so I hope to learn something from you guys here today. But I have prepared kind of a similar pair of slides here to talk through some points and make you aware. So starting from the top, again, we'll kind of preface it with feeder, make sure it's in good shape, make sure your chain's properly tensioned, that sort of thing. But then drum speed, would say start from your recommended setting and adjust per the condition. Again, with the concave, looking for that preseason parallelism and concentricity check. And again, probably starting with the recommended settings from the book. You're likely or potentially aware of the sectional concave, which is available, which gives you the ability to swap out the front portion of that concave in a little bit easier way. There's a cereal grain, which I've not listed, as well as a maize and a round bar, or corn and a round bar configuration. I'll show you that on the following slide. For the beater, there is a polyurethane beater blade kit, which is available, which can be used to help reduce the impact of the beater and the resulting damage there if the situation warrants. The rotary separator should be in the low speed position. Again, with cleaning and tailings management, for me, it's kind of the same message here. I would start with the recommended settings, acknowledging that the CX book settings tend to be a little tighter than the CR. I probably lean more towards a little bit more open setting if I can stand it. But again, trying to minimize the tailings to the extent that I can, because that's another. It's one more pass, like I said before, with that cumulative damage behavior. The more times you pass through these systems, the more potential you have to create damage. and likewise for the grain handling, and the rest of the system, again, looking for correct chain tensioning, looking for wear and any discontinuities in the system. So some of the kits that are maybe of interest from the CX combine. So there is a low speed drum drive kit. If I'm not mistaken, I think this kit reduces the drum range from like 300 to 900 RPM to a range of more like 250 to 750, which is probably the lower end of that. It's lower than where you're going to be, but is perhaps interested depending on your crop mix. The sectional concaves, like we mentioned, I've included the part numbers here for the round bar sectional kit. I guess just as a heads up, I did run into a situation last week with Kevin where the kit that's shown here wasn't currently available in service, but both of the components were. So if you're looking for these kits and the dealer doesn't have inventory of that, maybe ask them to check on a part by part basis. And then on the bottom here, we've got the maize or the corn style sectional kit. And then the polyurethane beater plate kit that I mentioned. So that's basically a polyurethane plastic strip essentially that can be installed on your beater to reduce the impact there at that point. So that's what I had prepared for you guys. With that, I'll open it up if there's more questions or with some potential topics listed here.
Yeah, thanks, Curtis. I think the big thing that we're all kind of anticipating is likely just with a late harvest running into likely wetter conditions, maybe a higher moisture grain, wetter cutting conditions. So I guess mostly what we're running into, or what we have run into, is scenarios where like you're trying to thresh out pods and you just can't set your combine aggressive enough without causing issues with splitting or crushed beans. And you did mention some really good ways on how to combat that, but that was like my main focus of trying to get ahead of some of those scenarios.
Okay. I guess from the team here, what have you found to be most effective for your regions when you're running into those challenges, and whether it's CNH product or whether it's aftermarket solutions? Is anybody have something that they really feel worked well or helped, understanding that it's a challenging situation and sometimes there's no perfect solution, but
Yeah, like Clayton, not to pick on you, but I was just thinking back to like 2019, I think was our last year where we maybe had like some wetter beans at harvest and it got late. Did you have anything that you found helpful, or like thinking back to that time frame, was there any questions that you had at that time that you wish you could have asked somebody?
That was that year does jump to mind too for me. That was such a funny year with how we were basically combining soybeans in snow
yeah
on top of ice. So it was so extreme. But what really stood out, I guess, when the moisture content is so high, how much more liberty you have to thresh aggressively, like with higher rotor speed, if you do have difficult beans to get out of pods. So,
Yep.
I mean, that is kind of the plus side to that higher moisture situation. You can be more aggressive and still maintain seed quality. But yeah, it's always such a difficult time when you're trying to get those beans off at the right moisture content to preserve that quality, and finding that balance between where that is and green seed, and knowing that in a normal situation that moisture content's going to drop quickly. And so you're trying to get out there at that right time and get it done. So I wish I had a better tip other than you got to hustle when you can and try to get it done. But everyone already knows that.
Sure. Yeah. And that kind of matches my experience as well. As sometimes you surprise yourself with the amount of rotor speed that you can put on it depending on the condition. You can also get yourself in a lot of trouble. And the worst conditions I've been in was when the top of the plant was frosted and was very green like that, and the bottom of the plant was basically 12 or 13% normal harvest, and now you're trying to ride both horses, and it's a real challenge sometimes. What, just out of curious, what, go ahead.
Yeah, no, it's often too, whatever happened last year, you can almost bet isn't going to happen this year. It always is that way.
Sure.
So a person can use last year as sort of like a metric, but you're gonna have to dig deeper often to figure out what this year is going to be.
Yeah, that's a good point. Just out of curiosity, what maturity beans do you guys normally grow up there?
Yeah, so we have like a wide range, but as compared to what you're probably used to, quite early. So we're growing anything from a 000, which would be like a 2300 heat unit bean and less, all the way up to like a 25, 50, 100 heat unit bean. So a 00 maturity product. Okay. So we've got a really wide range of production that we grow up here.
Sure.
But it makes it challenging. Like, I think one thing too that's been frustrating for a lot of guys the last couple of years, especially dealing with drought, is that by the time we get in to harvest some beans, they've already dropped from, maybe at the beginning of the day, we're like 14, 13% moisture, which is awesome. And then by like the heat of the afternoon, we're already under 12, if not less than that. I guess, do you have any tips on how to adapt to like some changing conditions throughout the day? And like, I know it's tough and like probably more operation specific, but
I think awareness is probably a big part of it, right? I mean, like you just touched on there can be a big difference in the way those beans react to a given setting as they shift from 14% down to 11% or something like that. And that can be really challenging. I guess, out of curiosity, is anybody or how many people on the call are have the IntelliSense automation on their combine?
I do not for me, Clayton.
We have it on our CX 8.80.
Okay. What's your experience been with that?
Like the OptiFan system and all that?
So the IntelliSense, in fact, and to be honest, I'm not sure if it's on the CX yet. So it's the grain cam and the sieve pressure sensors.
Okay, maybe I'm thinking of OptiFan then, where it's always automatically adjusting.
Yeah. So OptiFan, that was kind of like one of the predecessors to the IntelliSense system.
Right.
So since model year 19 on the CR machine, they're available with the New Holland. The New Holland trade name is IntelliSense, and it basically adds a grain cam to the elevator, which is constantly taking pictures of the grain sample, looking for splits and looking for foreign matter. It also adds pressure sensors to near the rear of the sieves, which are sensing sieve load before you get back to the sieve loss sensor. Plus it's using your existing sensors, your loss sensor, your rotor loss sensor, and your sieve sensors, and it's basically running all of that information through an algorithm, and every 20 seconds it's making a decision on the next change that it should make. So potentially every 20 seconds your combine is adjusting itself according to the conditions. And we've had really good feedback on that feature. We did have a little bit of a software issue last year, which has been resolved, but we've had really good feedback on that feature. And I guess if you guys haven't experienced that, maybe it's interesting to talk to your dealer and see if you can get a demo of that. But for that exact condition or that exact situation where the conditions changing throughout the day, I think it's really helped guys out to make them more productive. Plus it kind of takes you're making a lot of other decisions through the day, management decisions about trucking and this sort, whatever's broken down or whatever the case might be. And so it's kind of helping. It's an extra set of eyes, so to speak, on the process to help you out. So we've had, like I said, we've had really good feedback on that, and I would be interested to hear how it might work for you guys in your conditions. So
a good tip. You guys have
Okay.
anything else that you want to pick Curtis's brain on while we've still got him on the line?
And if something comes up after the fact, I'm certainly have Stacy forward it on to me, and I'll certainly do my best to get you an answer or help you out. And if if you have specific problems, or Kevin Johnston, our regional product specialist there, I'm interested to know. Like I said, I haven't been there yet. Maybe I need to make some plans to come up and do soybeans in your area. So with that, thanks a lot.
Sure.
I'll let you turn it over to James.
Sure. No, thank you. That was awesome. Yeah, I feel like you gave us a lot of really good tips, things that I wasn't aware of that you could add on after to make things maybe a little slower, easier on the crop. So those might be good suggestions for guys to try and add getting into soybeans here. So if you are able to stay on the call here for James's portion, you're more than welcome to.
Yeah, plan to listen in.
Yeah, first. Okay, great. So with that, yeah, I'll pass it over to James. And this is James's second presentation of the day doing this. So he's going to be saying this presentation in his sleep by the end of this. So thank you, James. He is from Ontario, and I've coined him the most knowledgeable storage specialist you'll ever meet. He has done some presentations for us in the past and is just a wealth of knowledge when it comes to anything storage related. He's an engineering specialist for OMAFRA and based in Vineland, Ontario. He was raised on a cash crop and hog farm in the Niagara region and completed his mechanical engineering degree at the University of Waterloo. His work at OMAFRA focuses on best practices, innovations, and environmental impacts of grain drying, storage, precision agriculture, field equipment, and on-farm energy use. So with that, I'll pass it over to James. And again, if you guys have any questions on storage-related questions, feel free to pop in and ask.
Yeah, thanks, Stacy. Yeah, please feel free if you've got questions, just jump in. I'm with my full screen here. I don't necessarily see the chat or things like that. So don't be afraid to ask. I appreciate the compliment, Stacy. I would say maybe you haven't met that many grain storage folks then. I mean, I try to bring lots of knowledge to this, but I recognize that, many of the farmers and people that I'm speaking with, have a lot more practical hands-on experience than I do. I mean, I was raised on a grain farm, and my father and brother still farm, and we have a drying and storage system. But in terms of hands-on experience, there's lots of people I talk to that have been doing this for decades. And so I try to bring something new and interesting to the conversation that maybe you haven't thought of before, or you think about it in a different light. For those of you that were able to join the Corteva presentations in March, for their meeting in late March there. Some of this will be familiar because I did present there too, but we thought this was a good time just before harvest to do a bit of a refresher, especially with the potential for some challenging harvest conditions. I know in Ontario we had a bit of a later planting, with some early wet weather. So sounds like you in Manitoba and elsewhere were facing similar things. It does bring some unique challenges, and thanks very much to Curtis for giving us lots of tips to manage things in the combine. I'm going to touch a bit on some grain storage research, both new and old, but still good, and highlight a few tools and tips that you can use when you're trying to manage your grain once you get it through the combine into your storage, whether it's wet or dry. What do you do with it, and how do you maintain it in good quality? So I'm going to first start with harvest timing. I know we talked a bit about this in Curtis's presentation, just saying, there's lots of different challenges, and, whether you harvest early or late, you could be facing different moisture conditions. So we actually took a look at this in a small study that I did with a couple of my colleagues in 2019. And basically we took a few samples throughout harvest in a few different locations in Ontario. And what we found, at least for moisture and germination, was that moisture varies quite a bit, and it depends a lot on the local weather. As you can see, we did face some challenging weather conditions during harvest. So somebody mentioned harvesting in snow. Yeah, we definitely had some snow in 2019 during some of the harvest points, and so that was interesting. And so the moisture did vary quite a bit, For the seed growers, though, the germination actually held pretty constant, with the exception of one plot that had some disease in it. But otherwise, even the stuff that we left till the following spring to harvest, the germ, the crop being out all winter in the weather, the germ wasn't appreciably affected. So that's, maybe somewhat comforting for a seed grower, in that, your harvest timing maybe won't have a huge impact on your germ. But you can also see with the moisture varying quite a bit. I would say if you have good harvest conditions, you get it off, even if it's a little wetter than you want. You can deal with the moisture in a bin, but what you can't deal with is maybe if you run out of good days to harvest and then have to leave crop in the field. Nobody wants that. When you do get the crop off the field, you got to decide what to do with it, and that's going to depend on the moisture and the temperature of that grain. And so what you can take away from this table is that your grain is going to be able to be stored a whole lot longer when it's dry than when it's wet. The numbers in the table represent the number of days roughly that you can store grain before it starts to spoil. So you can see that even very wet grain, if you store that at sub-zero temperatures, it's still not going to keep very long. But you get very dry grain, you can store it quite warm, and it'll still keep for a long time. So we have some decent control over the moisture by drying the grain. So do that. If you get it off wet, you do want to dry it down, and you do want to get it quite dry, especially if you're storing it for long periods of time. I know 13% is kind of the target for soybeans, but if you're planning to store it for long periods of time, and maybe seed growers, you're sort of looking for 6 months till the next planting season. But if you're storing beyond that, consider drying it down a little more than that. Now, the temperature that you're storing your beans at, obviously we can't control the weather, but the weather does vary quite a bit, and we store our beans in everything from 20 and 30 degrees in the late summer, early fall to -10 and even below. The good news is that that won't really impact your germ. In fact, the cold weather tends to preserve the germ longer, even in the higher moisture beans. Of course, as the weather warms up, the wetter those beans are, that germination is going to drop off very quickly. So you do need to be conscious of that. And once again, if you're in warm weather, the message is try and get those beans dry as quickly as possible to preserve that germ. Now, when you're talking about drying beans and you're using a high temperature dryer, you want to be conscious of the temperature that you're drying at as well. And this study came out of Brazil and looked at some typical drying temperatures ranging from 40 to 80 degrees centigrade. Your tower dryers can get even warmer than that. And they found, obviously, the higher temperatures, it's much more likely you're going to cook that germ, and your germination is going to be very poor. So if you are using a high temperature dryer with beans that are a little wetter, you want to be maintaining that drying temperature as pretty much as low as you can. 40 degrees centigrade or about 100 Fahrenheit, that would be probably the top end of what I would suggest. And something like 32 or 90 degrees Fahrenheit would be probably a better option. Give you a little more breathing room. It is going to take your beans a little longer to dry at those temperatures, but we're growing seed here, and that germ is all important. So we do want to take steps to keep that in good condition. The other thing you do have to watch is relative humidity. Now, I know you're sitting there thinking, well, geez, I have a temperature setting on my dryer, but I can't control the relative humidity. Well, that's true, but by controlling the temperature, you do affect the relative humidity. And as you warm up the air, if you warm up very humid air, you're going to dry it out. And I'll explain a bit more about that on the next slide. The bottom line, though, is when your relative humidity drops below about 40 to 50%, you really start to see a big increase in seed coat cracking. And then you drop lower than that, you'll actually get the beans splitting. Of course, for seed, that kills the viability. So again, you want to be drying it at a lower temperature. That's going to keep your humidity warmer, or humidity higher, pardon me, and keep those beans in better condition. Now, if you think about humidity, if you can remember back to maybe your high school or university science class, maybe that was a little further back for some of you than it was for me. So let me just give you a little refresher here. You think about the air around you. Air has a capacity to hold water, and you can picture it kind of in your mind like an empty cup, right? And that cup represents how much water air can hold. And that changes at different temperatures. So let's say we had air at 0 degrees. I mean, it's much warmer than that today, but just as an example, 0 degree air, it can hold a certain amount of water. We'll call it 1. You fill that cup right up with water. That's essentially, you know, a very extremely humid day. Maybe it's even raining. It's 100% humidity. That air couldn't hold more water if it tried. That's not going to do much for us in drying. In fact, if we try and pump that air through our grain, it's going to make the grain wetter. But we can heat up that air, and by heating it up without adding any moisture to it, first of all, when we heat air, we increase the capacity of air to hold water. So by heating air up by, say, 10 degrees, we've actually just about doubled its capacity to hold water. But if we haven't added any additional water, now we're at 50% relative humidity instead of 100. So all of a sudden there's spare capacity there. And if we pump that air through some grain, it's going to have some room to absorb extra moisture from that grain and dry it out. And we can do the same thing again, heat it up some more, another 10 degrees, that'll drop it by another 50%. So now we're down to 25% relative humidity. And this air is very good for drying, and we can keep going this way. In fact, that's how a high temperature dryer works. You heat the air up to, say, 40, 50, 80, 100 degrees centigrade. You essentially get 0% relative humidity, and that air will dry beans or other grain very quickly. In fact, too quickly sometimes, we have to pull the grain out of the dryer before it over dries it. Now, you may have seen a chart like this before. It's called an equilibrium moisture chart. And this tells us the influence of temperature and humidity on the moisture of grain. So as an example, I'm sitting in a room here. It's probably about 25 degrees centigrade. You know, it's a nice warm summer day here in Ontario. And let's say it's 60% humidity in this room. Well, if you look up those two on the chart, you'll see that if I had a pile of soybeans in this room with me, eventually those soybeans would reach about 10% moisture. That's just the way it works. The beans will equalize their moisture with the air around them, and it works out to be about 10%. So if I cool the room down, turn up my air conditioning, the moisture is going to creep up in these beans. And if I add, put a humidifier in this room and make it wetter, those moisture is going to creep up. So we can use this to help us understand how much our grain is going to dry simply by using the air around us and using the fans that are on our bins. And what you'll find is that 70% relative humidity is pretty much the sweet spot for most grains. You'll get in that range of where you want to be for soybeans, 12 to 13%, depending on your outdoor air temperature. Now, again, you're sitting and thinking, well, I can't control the humidity, but you can heat up that air a little bit if it's too wet and dry it down. Of course, if your air is too dry, you can put water back into the air. That's, it takes a lot of water to do that, and maybe it's something you don't really want to worry too much about. But it is possible to re-wet beans that are too dry as well if you wait for kind of a more humid day. Now, this can be a lot of numbers that I'm throwing at you. There are some tools that can help, and this is one that I really like. It's called Bincast. It's available on decisionfarm.ca. It is an Ontario-based tool, but it does work in Manitoba. I can't promise you how reliable the weather data is because it does pull on localized weather stations, and I don't know what data sources Weather Innovations happens to be using in Manitoba, but you can choose a Manitoba location and it will pull data. I'm not sure about United States. You'd have to log on and see, but you can do that. You will have to create a free account on the website, but that allows you to save your location as well, so you don't have to always re-enter it. And what this tool does is basically gives you a weather forecast for the next 5 days. For every hour, what's the temperature and humidity expected to be, and then what does that mean for your grain moisture? So you can use this to help you plan. If you want to aerate your beans or dry them out, you can use this to help plan when might be a good time for the following week to run your fan. Because of course the fan is the tool that we have to condition our grain. It's really the only one we have, and depending how much airflow you have and whether you're adding heat, you can do different things. If your grain's very wet, you want to use that fan to dry it down. You'll need a really big fan. You probably don't want very much grain in that bin, or you have a dedicated dryer. You will need to add heat. You can dry it in a few hours, but you do want to be very careful of over drying or grain damage. If you've got a bit more time on your hands, your grain's not quite as wet, you can put it in a regular storage bin, maybe just with a larger fan on it, and you can dry it down. It'll take you, a few days, maybe in a few weeks. You can speed it up a bit by adding some low-grade heat to it, but it's very gentle, low risk of over drying. and you will get that grain dry. And of course, if it's already dry, it's come off the field dry, you still want to use that fan, mostly just for cooling and maintenance. You're not going to do much drying when you're just aerating, and you don't need to worry about adding heat. But your fan airflow is not maybe what you thought it was. Different fans have different capacities. Even 5 horsepower fans, they're not all created equal. So take a look at what kind of fan you have and call your fan manufacturer, get the fan chart from them, and it will have different airflows depending on the static pressure. And the pressure is basically how hard does your fan have to work to push air through the grain that it's facing. That, of course, is influenced by the depth of grain as well as the speed of the air. So it's a bit of math here to try and figure out how much static pressure you have, how deep your grain is, and how much airflow you might have per bushel. I would say it's worth taking the time to do that, but there is even an easier way. You can just measure your static pressure. You can do that by putting a gauge on your bin. You can get a gauge measured in inches of water. If you're not familiar with that unit, 1 PSI is about 28 inches of water. So we are dealing with pretty low pressures here. And so, but if you don't have a gauge like that, or you're not sure where to get one, you can get just a clear piece of hose, maybe something that you'd otherwise put on your sprayer or something like that, fill it with water, stick one end into your bin plenum and turn on the fan. And you'll see the height change in that tube when you bend it into a U shape. And that height difference is literally the pressure in inches of water that your fan has to work against. So then you can take that measurement, look back at your fan chart and see how much airflow you're actually getting off your fan. Then you can figure out how many bushels you got in your bin and what's your airflow per bushel, and then you can use that to help estimate kind of your time frame for aeration and drying. Now, if you like online tools, here's another one from Minnesota. I like this one because it'll tell you, roughly what your airflow might be as you fill that bin to different depths of grain. They've got a whole database of fans in here, so you can probably find the fan that's on your bin in their database, and it'll give you a good idea of what your airflow might be. You can also use this if you're building a bin and you want, to target a certain airflow. Say you're doing a natural air drying bin. Say, how big a fan do I need? It'll tell you roughly, what the fan horsepower you might need for that is. Now, I know many of you use hopper bins. So maybe this is a little less applicable to you, but if you've got a flat bottom bin or a dryer, you certainly want to be coring out that bin before you run your fan. And that basically means pulling out the central section of grain with flat bottom bins that kind of empties in a funnel shape. So you will get that central core coming out first. That just pulls out the highest concentration of fines and weed seeds and small particles that get in there. Just due to gravity, that's where they end up. So you do want to be doing this if you have a bin that's conducive. Of course, a hopper bin, you kind of get mass flow going on, so you don't really get the same funnel shape emptying. So you'll have to deal with that chaff separately, either in the combine by fine tuning your sieves and your fan speed and things like that, or perhaps passing the grain through a grain cleaner before you put it in the bin. But the reason you want to get the fines and stuff out is that they will cause problems with aeration. You get those particles in there, they're going to block air passage. And so you'll get portions of your bin that aren't getting as much air as other portions. Of course, air takes the path of least resistance. Same principle here. You do also want to level out your bin. I know this can be a bit of work, but it means it will be less time for drying and aeration because, of course, your grain is going to be much deeper in the center than it is on the outside. And so you get the air just going up around the outside. You get a portion in kind of the top center that really doesn't get much airflow. It's going to stay wet and a whole lot longer. It's not going to cool as quickly. So just to be able to preserve your crop, you want to be conscious of that. This is a good job for maybe a young farmhand or some children or grandchildren that have a little too much energy. Of course, if you are putting anybody in a bin, you need to be very safe about that. And we'll talk more about that in a minute. Now, as I mentioned, drying in a bin can take a long time. So if you don't have weeks to wait, think back to that first chart we looked at in terms of moisture and storage time. You may want to consider a higher temperature dryer, but you can dry it in a bin if you've got a big enough fan. As the weather goes on in the season, it's going to take longer and longer. You can add some heat to speed it up. It's tough to predict, for each individual bin or situation. So this is just a generalization, but, expect it to take several weeks if you are using natural air, and grain dries in a layer. So it's going to dry from the bottom up. And so you can watch it, and when you see the moisture at the top of your bin start to drop, then you'll know that the drying process is almost complete. Now you can add some heat, as I mentioned, it'll speed it up a bit. And really what you're trying to do is not warm the air so much as dry it out, so that your air going through that bin is hitting that relative humidity where you want it, so you get the right equilibrium moisture. You can do that with a portable heater such as this, or a bolt-on one to your fan. They are available, and just watch how much heat you're adding. You don't want to overheat it because you'll end up over drying your beans. So you probably want to target something in the 10 to 20,000 BTUs, or 3 to 6 kilowatts for every 1,000 CFM of fan that you have. That's going to allow you to drop that relative humidity by between, say, 10 to 30%. So even on a very humid day, you're going to be able to get that humidity in that range of 60 to 70% where you want it for the best drying. It's best if you have a heater that has some capacity to adjust the heat. It's not just on off, but you can use this. And then if it's a very humid day, you can crank that heater up a bit as the humidity drops off. You can turn it down. So yeah, there's definitely some hands-on management that's needed here when you're drying grain this way. But it is a very gentle process, and it does do a good job, but it does take some time. Now, maybe your grain's already dry and you're just thinking, well, I need to maintain it in the bin. Or maybe, as Stacy mentioned, sometimes it does come off the field very dry, even at 12% or less, but it's still pretty hot and you want to cool it down. So you definitely want to be running your fan anyway once it's in the storage bin, both to cool it down initially and every time the climate continues to drop. We don't want too much differential between our beans in our bin and our outdoor temperature. So depending on the kind of grain, oh, sorry, somebody jumping in there. Depending on the kind of grain you have, how dry it is, you maybe need more or less airflow. I mean, it's going to depend on the fan you've got on your bin, but just keep that in mind. And you can see kind of the range of time it takes to cool the grain. That's not drying, that's just cooling cycle time. So anywhere from a couple of days up to maybe even a week if you've got a smaller fan on there. And you can see over time, you know, the temperature obviously drops off from summer to winter. So you do want to be running regular aeration cycles kind of every time you get another 5 or 10 degree drop in the average temperature until you get that grain nice and cold. As we saw already, freezing grain isn't a problem for germination. So you can hold it nice and cold over winter. And then in the springtime, you know, you can consider warming it up. I mean, certainly by the time you plant it, it's going to need to be not frozen. But do that carefully when you're warming it up. You still want to keep it as cold as possible, you know, 5 degrees or 10 at the maximum. So run that fan at night. And if you're keeping it into the summer, you want to watch that very closely. The other reason you want to aerate is because if you don't, you'll get moisture moving within the bin itself. As the air cools down in the winter, the grain near the outside will cool down. If you've got warm grain in that bin, you'll actually get condensation in the roof space of your bin. So if you ever seen that moisture came from inside the bin, and that means you probably need to aerate your grain. The opposite thing happens in the winter. You'll get the bin warming up with very cold grain. You'll get air moving and you'll get moisture forming down at the bottom. And you won't find that until you try and empty the bin. And you won't be able to because it'll be stuck. So this is why it's important to keep that grain temperature close to the outdoor air temperature, just to minimize the change from the outside to the center of your bin and prevent this kind of unrestrained air movement from happening. You do want to watch your bins very closely, probably every 1 to 2 weeks, maybe a little less often in winter when it's frozen down, just because it'll spoil a lot slower. But you know, use your eyes, use your nose. We've all smelled bad soybeans and it's not pretty. And of course, keep written records of your inspections. There's nothing that can, you know, pass for a manual inspection is really important. Of course, by the time you see or smell something, it could mean the problem might be too late to deal with, but it's still important to do those checks. There's other ways you can monitor too. Maybe some of you have temperature or moisture cables in your bins. That's a great way to keep tabs on what's going on where you can't see. But there's some newer innovations as well. The nice 3-dimensional image you're seeing is actually kind of an MRI type scanning system that you can put sensors in your bin. It'll tell you the moisture all throughout your grain, so you can see if there's any wet spots. Of course, it's, you know, probably as expensive as you think it might be, but it is available. It is quite costly, but for seed, maybe it's worth the expense. Perhaps a simpler and less expensive option, you can get CO2 sensors now that'll just hang in your bin space, in the attic space. The principle behind that is that CO2 will start to be produced as grain spoils, and that moves through the grain much easier than temperature or moisture does. So you'll actually be able to detect that much sooner than you would see it on a temperature cable system. The other benefit is that all these systems can integrate with your fan. So if they detect higher moisture levels or problems, they can automatically turn on your fan and keep that grain in condition. They can watch compared to local weather and stuff like that too, to make sure they're running in the right humidity range. Something to consider. You know, talk to your bin suppliers, and they can give you some ideas of what these systems might be able to do for you. Finally, for safety, I can't stress this enough. I mean, there's always a few deaths every year from grain bin entrapment. 3 to 4 people doesn't sound like a lot, but if it were you, you'd be pretty concerned about that. So don't go in a bin unless you absolutely have to. If you know there's crusting in that bin, be extremely, extremely careful. Make sure you're using proper safety equipment. Tie off with a proper safety harness and a rescue line, not just a rope tied around your waist. Never go in when an auger is running, and never go in without somebody there on the outside of the bin that can help you out or go for help if needed. If you're buried in grain, a rescue is not simple. It's like quicksand. You can't just pull yourself out. They have to use specialized equipment. So be very, very careful when you're doing that. So in summary, you can harvest seed soybeans wet and dry them. That's pretty safe. As if you do a good job with drying, you're not going to impact your germ. Freezing seed soybeans is safe, especially if you haven't got them fully dry before winter. That can be a good option, and they won't appreciably spoil at very cold temperatures. You can use some heat to dry them, and you'll be able to do that without killing your germ. And finally, you do want to aerate your beans, keep them cool and dry once they're in storage, just to maintain their viability. So with that, here's my contact information. I'm happy to take any questions now. I think we have a few minutes, or if not now, if you have questions at a later date, please feel free to reach out anytime. I'm based in Ontario, so I might not be able to drive to your farm in Manitoba, but I'm happy to answer questions, and I'm always interested in helping people keep their grain in good condition.
Awesome. Thanks, James. You have so much good information for us going into this season. I think it's really very pertinent, and we'll stay on top of hopefully not running into some super wet beans. But if we do, I'm just glad that we've got you on tap. I sent you a couple questions ahead of this, but like, I think for us in Manitoba, like there's a couple things. One, when we run into high moisture beans, we have such a short window of time to realistically dry them, because we're trying, as a company, trying to figure out which bins we can haul in first. So it does kind of impact our like slow drying time, which we ideally want, but we also need to be realistic with our time frame. So I guess for us, we have been adding a lot of indirect heat source to our bins to try and speed things up a little bit. So I'm glad you touched on that, because I guess any tips you have around that is super helpful for us, because we are probably going to be running into scenarios like that this fall.
Yeah, as I mentioned, indirect heat can really help. It'll help warm it up a bit, which does speed it up a bit. And really, again, the goal is to dry out that air a bit more. You can put some heat in there. It's still going to take you probably longer than in a high temperature dryer to dry it. So I know, you might be thinking, well, what if I run that fan and kind of over dry my bottom a bit, leave the top wet, and then maybe I can blend them and equalize it. The challenge is trying to figure out where is that balance point, and trying to do that and turn the beans at the right time. That's going to be a tough thing to do, but I guess, if you're adding more heat, I would suggest put less beans in the bin so that you're drying it faster and you have a bit better control over that. Otherwise, try and add kind of enough heat so that you can get that humidity where you want it, and then you can run your fan as much as possible. So, I mean, you know, from an engineering standpoint, I can envision a system that would, you know, basically have a humidity sensor on the outside, and then run your heat till you can hit exactly the humidity you want all the time, and then you could run that fan 24/7, and you'd be able to dry that grain down as quickly as possible. I would suggest that, you know, another way to do it is simply put a bigger fan on it. It will go faster. Obviously, you deal with more static pressure then, so then you need even a bigger fan to make sure you're getting the airflow you want. But if time is a consideration, airflow is your best way, combined with then a larger heater to accommodate that larger airflow. But as an example, I mean, I was working with a grower here in Ontario that was doing some drying in his bin. Now, he only had the grain 3 feet deep. This was corn, but he had about 6 cubic feet per minute of air per bushel, which is quite a lot for a natural air drying bin, just because he didn't fill the bin very full. So he was able to take 28% corn, which is extremely wet. I wouldn't suggest that for bin drying. But he took 28% corn and he pulled it down to, you know, 14, 15% in the matter of a couple of weeks, just because he had so much air on it. So it is doable, but airflow is key. And so that would be my suggestion. Look at maybe a slightly larger fan if you are finding not enough time to do the drying that you want to do.
That's awesome. I guess one thing too that kind of comes to mind is, like, we really focus on trying to cool those beans down like immediately at harvest, and especially over the last couple of years when we've started harvest, like end of August essentially, with drought, we've been harvesting in some pretty hot temperatures, been hot and dry. So to run the fans to cool that grain, like, how much is too much, and are we causing more damage running those fans longer than what we're maybe thinking that we are?
Yeah, so if I go back to this slide, you can see kind of some expected time frames for how long it's going to take to cool the grain. Now, in this time frame, you probably, you know, especially if you have a slightly larger fan, you probably won't be doing a lot of drying here. And again, you can watch the top of your bin. So if you put it in a bin, because it's going to cool from the bottom up as well as dry from the bottom up. So as soon as you see the top of that grain, the top of that bin, you see that temperature dropping, you know that cooling cycle has made it through the bin, and you can then turn your fan off if you're happy with the temperature that it's at. So that'll allow you to you know, not end up over drying. Yet you will pull a little bit of moisture out of the bottom of your bin. It's unavoidable, but I think, you know, if you think back to this first chart here, you know, you leave that grain too warm. I mean, I guess if it's pretty dry, you know, your risk is lower. But if you leave that grain too warm, you know, you're compromising your ability to store it for a long period of time. So it is important to get that field heat out, and but watch the grain at the top of your bin, because once that top of the bin starts to cool down, you know that you've completed your cooling cycle and you can turn that fan off.
Those are good tips. Thank you. Does anybody else on the call have any questions? I kind of monopolized the question period, sorry.
I'll make sure that Stacy gets a copy of this presentation as well, so that you can send this out. I know I put a lot of information in here. I probably tend to put too much and make everyone try and absorb it in a short period of time. But by all means, like, I'll make sure you get this out, and so you have these charts and references handy. And as I mentioned, please feel free to get in touch with me anytime if you got questions.
Awesome. Thank you so much. Okay, well, we're at time, so I think we'll end the call here. So thank you, everyone who joined the call, especially to the presenters. You guys have such great information. I hope that, you know, we can be even a quarter of the smart that you guys are after listening to you talk, so appreciate it. And again, if you guys have any questions for the presenters, I'll make sure I've got their information, and we can either reach out to them directly or contact them through me. So with that, wish you guys all a safe and successful harvest ahead. For the Manitoba guys, you'll probably hear from me again before you get started with harvest, but for everybody else, take care. Thank you.
Thank you.
Thanks very much.
Bye.
Thanks, guys.